Okay, class, we're about to start section 9.1, solving quadratic equations by the square root property. How do you recognize a quadratic equation? When the equation is in the form ax squared plus bx plus c equals 0. That's one of the ways that you recognize a quadratic equation. Now, we've learned one method so far for solving quadratic equations, which was factoring. Example, we had x squared minus 25 equals 0. Now we know that this is the difference of two squares. So we would do x minus 5 and x plus 5. And that's equal to 0. So we would set each one of these parentheses individually equal to 0. And solve. So we would add 5 on both sides here. And x equals 5. Here we would subtract 5 on both sides, and x is equal to negative 5. So your final answer will be x is negative 5 and also 5. Now this does not make this answer undefined, so that is your final answer. Now, we go here. There's another way to solve the equation called the square root method. Now this is how the square root method goes. You add a variable to the exponent on one side and all of the numbers on the other side. So we would add 25 on both sides. And we would have x squared is equal to positive 25. Now, we would take the opposite operation of to the second power, which would be the square root. The square root of x squared is x. And the square root of 25, when you're dealing with an equation, is positive and negative 5. That's where you see this plus or minus sign. So you could write it like this, or you could write it as x equals negative 5 comma 5, which is the same answer that we got in the previous problem. Now, it says objective 1, solve quadratic equations using the square root property. Let k be a non-negative constant, then x squared is equal to k has two solutions. And the two solutions will be plus or minus whatever the square root of k is. And that also means that it will be the square root of k and also the negative square root of k. And I should have put x equals there. So either one of these would be an acceptable answer for that. Okay, now it says solve x squared is equal to 9. So we have x squared equal to 9. We will have to take the square root of both sides. Square root of x squared is x, and is equal to positive and negative 3, because this is already set up in an equation. Now we have x squared is equal to 7. So we have x squared equals to 7. We'll take the square root of both sides, and we have x is equal to positive and also negative square root of 7. Now, we have a warning here. It says, warning, the equation x squared equals 9 has two solutions, 3 and negative 3. Recall from section 9.1 that the square root of 9 is the one number 3. Now, remember, this is an equation. When you have an equation, that's how you get the two answers. This right here is just an expression, and that's when you get the one answer. So that's the difference. Expression, you get 1. Equation, you could get 2. Okay, now it tells us to solve this. We have x squared is equal to 12. We'll take the square root of both sides. Now the square root of x squared is x, and the square root of 12 is plus or minus the square root of 12. Now remember, the square root of 12 has a perfect square in it, which is 4. So we need to take that perfect square out. So we have plus or minus the square root of 4 times the square root of 3. Because we know 4 is the perfect square from 12, and 3 will be left over. So your final answer is x is equal to plus or minus the square root of 4 is 2, square root 3. And that's it. So it's a positive 2 square root 3 and a negative 2 square root 3. Now we go here to the next one. We have x squared equals negative 25. So we have x squared equals negative 25. We would take the square root of both sides. The square root of x squared is x. And you know we cannot take the square root of a negative number. So our final answer here is no real solution. So that is your final answer. There's no real solution. Now, we come down here to C. Now, with this problem here, we have to get the r squared by itself first. So we will add 50 on both sides. So we have r squared is equal to 50. Now, we have to take the square root of r squared on both sides. And we have r is equal to plus or minus the square root of 50. Now, 50 has a perfect square in it. The highest perfect square that we could pull out of 50 is 25. So we have the square root of 25 times the square root of 2. Now, we'll write our r is equal to plus or minus the square root of 25 is 5 times the square root of 2. And that's it. Now, we go down here to this next example. It says to solve an equation of the form ax squared plus c equals k, we isolate x squared on one side of the equation before using the square root property, which we basically did already. So now here for a, we need to get y squared by itself. So first we'll subtract 1 on both sides. And we had 2y squared is equal to 50. Now we got to get rid of this 2 off of the y squared by division. So to be y squared is equal to 25. Now we can use the square root property. So we'll take the square root of y squared, square root of 25, which will give us y is equal to positive and negative 5. And that's it for A. Now we go to B. We have to add 2 on both sides. So we have 3t squared is equal to 7. Divide each side by 3. And t squared is equal to 7/3. Now we would take the square root of both sides here. Now actually the square root is supposed to cover the whole 7/3. So that's t is equal to positive and negative the square root of 7/3. Now we know we cannot leave this 3 under a square root. So our next step here is to first separate this radical. So we have the square root of 7 all over the square root of 3. Now we have to get rid of this square root of 3 in the denominator. And we multiply our numerator and denominator by the square root of 3. So we will have t is equal to, it's still positive or negative, square root of 7 times square root of 3 is the square root of 21. All over square root of 3 times square root of 3 is the square root of 9. So we have t is equal to plus or minus the square root of 21 all over 3. And that is the final answer. Now, we scroll down here to example 4. Now, example 4 tells us to solve, but if you notice, this time we have a parenthesis. So we still would do the square root method because this is the value squared equals to a number. So what we would do here, we would take the square root of both sides to get rid of that square. And then we would be left with x plus 5 is equal to positive and negative square root of 3. Now we have to get rid of this 5 from the x. So we'll subtract 5 on both sides. And x is equal to negative 5 plus or minus the square root of 3. And that's it. Now we come to B. It's the same thing. Take the square root of both sides. Now this will give us x minus 7 is equal to, now this is plus or minus, but we know there's a perfect square in 27, which is 9. So this will give us square root of 9 times square root of 3. So we have x minus 7 plus or minus, this would be 3 square root 3. Now we will add 7 on both sides. And x is equal to 7 plus or minus 3 root 3. And that's it. Now, we scroll down here to C. C is basically the same, but C is actually going to be kind of short. We'll start it off the same. Take the square root of both sides. Now, once we see here that we have the square root of a negative, we know our answer is no real solution. There's no need to continue this. So there's no real solution. Okay, now we would take the square root of both sides. Square root in the square would simplify out, and you have p minus 7 is equal to 0. You don't put plus or minus 0 because remember 0 is not positive or negative. So we will add 7 on both sides, and p is equal to 7. Now we have a few more definitions here. We have objective 2, solve problems using the Pythagorean theorem. An angle at 90 degrees is called a right angle. If one of the angles in a triangle measures 90 degrees, the triangle is a right triangle. The side opposite the right angle is the triangle's longest side. We call that side the hypotenuse, and we call the two shortest sides the legs. So we go here, this is the right angle here. So directly across from it is our hypotenuse. Now once you find this hypotenuse, all the other sides, the other two sides are just the legs. So it's quite easy to identify. Okay, now the Pythagorean theorem. If A and B are the lengths of the legs of a right triangle, and C is the length of the hypotenuse, then A squared plus B squared equals C squared. So that's like leg squared. This is like leg squared plus leg squared is equal to the hypotenuse squared. Leg squared plus leg squared equals hypotenuse squared. This is the same thing as A squared plus B squared equals C squared. Now we come to example 5. It says the length of two sides of a right triangle are given. Find the length of the third side. Now, remember, we would take A squared plus B squared equals C squared. Now, if you notice here, the side that's missing is the one directly across from the 90-degree angle. So we need to find the hypotenuse, which would be our C. It doesn't really matter which one of these that you make A or B. So it'd be 5, I'm going to make 5A and 6B. 5 squared is 25, plus 6 squared is 36, equals C squared. 25 plus 36 is 61, and it equals C squared. Now, we would take the square root of both sides to get C by itself. So it'll be the square root of 61 is equal to C. Now, the reason why we didn't make this plus or minus is because this is a measurement. We're measuring a side. So when we measure a side, we don't have a negative value. You don't go a negative distance. So you have the square root of 61 is equal to C. Now, we go here to B. Now, if you notice here, we have the hypotenuse and we have a leg, but we're missing a leg. So we have A squared plus B squared equals C squared. We could let 4 be A. We don't know what B is. And C is 8. So we have 16 plus B squared equals 64. So we subtract 16 on both sides. And we'll have B squared is equal to 48. Now we take the square root of both sides. And we will have, let me take this up here. We will have B is equal to the square root of 48. Now, 48 has a perfect square in it, which is 16. So this would be the square root of 16 times the square root of 3. The square root of 16, we know is 4. So it would be 4 square root 3. That would be the final answer for that problem. Okay, let's look at example 6. It says, let A and B represent the lengths of the legs of a right triangle, and let C represent the length of the hypotenuse. Values for 2 of the 3 lengths are given. Find the third length. If you notice here, we have A and B, so we don't have C. So we need to find what C is equal to. A is 4, B is 10, and C we don't know. 4 squared is 16, 10 squared is 100, and it equals C squared. 16 plus 100 is 116.